Hey, welcome. You know that feeling when you're staring at lecture notes on network security and it looks like you're trying to read a completely foreign language? Well, if that's you, then you are in exactly the right place. Today, we're going to take all those dense concepts and make them super clear. We're going to break down how security monitoring works and how to write the rules that make it all happen, one step at a time.
All right, so here's the game plan. First, we're going to start with the big picture. How do you even spot bad stuff on a network in the first place? Then, we'll get introduced to our main tool, this digital guard called Suricata. After that, we'll learn to speak its language, we'll take a real-world rule and break it down, and then, the best part, we'll put it all together and build one ourselves.
So, first things first, let's talk about the big fundamental challenge here. With this constant flood of data flying across a network, how do security systems actually find the needle in that digital haystack?
Yeah, it's a huge question, right? And it's the perfect place for us to start. I mean, think about it. It's like trying to find a single whispered conversation in a massive, noisy stadium. So how do you do it? Well, it turns out in network security, there are two main ways to tackle this.
Okay, the best way to get these two ideas is with an analogy. On one hand, you've got signature-based detection. Think of this like a security guard at a club with a wanted list. If your ID matches a name on that list of known troublemakers, you are not getting in. It's simple, and it's super effective against threats we already know about. Then, you have anomaly-based detection. This is more like that veteran security guard who's worked in the same building for 20 years. They just know the rhythm of the place. They notice when something feels off. You know, a door that's usually locked is suddenly propped open at 3 a.m. It might be nothing, but it could also be the first sign of a brand new attack that no one has ever seen before.
So, having these great ideas is one thing, but you need a tool to actually do the work. And that's where this really powerful piece of software called Suricata comes into the picture. So what is Suricata? Well, the simple way to think about it is that it's our digital security guard. The technical term is Network Intrusion Detection and Prevention System, or NIDPS. But really, its entire job is to just sit there on your network, watch all the data flying around, and check it against a rulebook that we create to spot any signs of trouble.
And this is exactly why so many people use it. It's not just that it's free and open source, which is amazing, it's that it's so flexible. It can hunt for those specific signatures we talked about, but it can also spot weird patterns. And get this, you can set it up to not just send you an alert, but to actively block the bad traffic right then and there. And maybe the best part? There's this massive global community constantly writing and sharing new rules to keep up with all the latest attacks.
Okay, this brings us to the most important part of this whole thing. How do we actually tell Suricata what to look for? Well, we have to learn to speak its language. We have to learn how to write a rule.
Okay, I know. You look at this and it looks like a line of code, maybe a little intimidating, but trust me, don't worry about it. Just think of it like a sentence. It is a subject, a verb, an object, a really clear grammar, and we're going to break down every single part of it piece by piece so it makes total sense.
First up is the action. This is basically the verb of our sentence. It's what you're telling Suricata to do if it finds a match. Do you want it to pop up an alert? Or maybe just quietly log the event for you to check later? You could have it just pass and ignore it. Or you could get really serious and tell it to drop the traffic completely.
Next, we've got the proto, which is short for protocol. This is where we specify the type of conversation we're listening to. Are we looking at web traffic? That's usually TCP or HTTP. Or are we interested in something else like DNS lookups?
All right, now we get to the who and the where. Every conversation on a network has a source, that's who's talking, and a destination, that's who they're talking to. We define this with IP addresses and these things called port numbers. You can think of a port number like an apartment number on a building. It tells you exactly which application the data is for.
And then there's the direction. It's just a little arrow, but it is so important. It tells us which way the traffic is going. Are we watching for something coming into our network from the big wide internet? Or are we looking for something on the inside that's trying to get out?
And that brings us to the final piece, the options. Everything inside those parentheses. This right here is the real heart of the rule. This is where we put all the juicy details, the specific clues, the patterns, the conditions that make something suspicious.
All right, so we've got the basic grammar down. Now let's dive into those options a bit more and look at some of the most common and most powerful ones you'll be using.
Yeah, these are the ones you're going to see all the time. MSG is pretty straightforward. That's the message you write for yourself, so when the alert pops up, you know what it means. Flow is really useful. It lets you check if a connection is already established, for example. You might not care about the initial handshake, just what happens after.
And then side and rev. Think of these as just good housekeeping. Side gives every rule a unique ID number, and rev is the revision. This is absolutely critical for managing thousands of rules and sharing them with other people.
Now, the content option, the original notes actually had a line in German about this, saying it's sometimes the most important part of the rule. And you can totally see why. This is what it's all about. This is the core of that signature-based detection we talked about. The content is the literal string of text, the exact data. It's the signature that's on our guard's wanted list.
Okay, we've gone through the theory, we've learned the grammar of a rule, now it's time to stop talking and start doing. Let's apply all of this and build a rule together to solve a real problem.
All right, so here's the challenge. Here's what we need to do. We need to write a rule that's watching for a very specific thing. We only care about outgoing web traffic. We need to make sure the connection is already established. And then we're looking for the specific string /admin somewhere in the URL. If all of those things are true, we need to log a specific message.
And here it is. This is the solution. Let's walk through it together, and you'll see how it matches our challenge perfectly. Alert, TCP, that's our action and our protocol. The arrow and the IP variables show traffic going from our home network out to the external internet on the standard web ports. And then inside the parentheses, it all comes together. We've got our custom message, we've got our flow condition to make sure it's an established connection, and there's the star of the show, URI content /admin. That's what tells Suricata exactly what to look for in the URL.
And there you go. You did it. Seriously, we just went from a potentially confusing page of lecture notes all the way to building a real working security rule. That is a massive leap forward in understanding how this all actually works in the real world.
So to wrap things up, I want to leave you with a question. You now have this really powerful new skill. You can literally tell a digital security guard what to watch out for on a network. So, what's the very first thing you'd want to look for? What problem would you solve first? Thanks so much for joining me for this explainer.